Okay, so today, guys, we're going to go through how to do the derivative of the one that's in question 5. So you'll notice questions 6 and 7 are pretty similar. Now, obviously, if you want to try 5 before watching this, that's also fine. I don't want to take away opportunities for you to try some, but I thought we could work through one of these together as well. So just remember, with the quotient rule, my first job is always going to be to write out the function itself. So I'm going to do that. I've picked this one because it has a third in there. I thought, make things a little different. So ux in this case equals to equals to 2 root x. Now remember, in that format it's pretty useless to deal with, so I'm going to choose to write this as 2x to the power of a half. Okay, and in this case v, now I'm actually going to get you guys used to some new notation as well while I think of it. It's okay to use shorthand with the product and quotient rule, so we can just use u and v rather than ux, vx, and it just makes it a little bit tidier in my opinion. So we're going to give that a go. So v in this case equals to 1 take x. Okay, so u dash equals 2. So we bring the power out the front, remember, so half times 2 just gives me 1. And then I've got x to the power of, now subtract 1 from my power, remember. So a half subtract 1 gives me negative a half. So that's my derivative of u. So that's u dash. V dash equals to, well, the derivative of 1 is 0. The derivative of negative x is just negative 1. So this means that dy dx, oops, that's a u, Mr. Haggett, not an x. Dy dx equals to u dash v take uv dash over v squared. So you'll notice I'm always writing out the rule with these. Really important step. I do find it's going to avoid errors. It also lets the examiner know you know what you're doing. Just in case you did sub the wrong thing in, they can at least see you knew what you wanted to do. You've just made a small error. So now we're going to go, all right, well, u dash in this case is x to the negative a half. And then we've got times by v, which is 1 take x. Okay, and I've got take u v dash. So in this case, u is 2 root x times negative 1. Okay, and this is all on 1 take x squared. All squared, that is. Okay. So we look at that and we go, usually this is where we'd leave these. We don't have to simplify them. But part B wants me to find when does this equal to 0 and when does this have an undefined value. Okay, so we're going to give that a go now. Okay, so to do that, my first step is I really need to make this derivative look a bit more functional because I can't really assume a lot of things in its current layout. So I'm going to start with this x to the power of a negative a half. I really want to write that as 1 over root x. And then I go, that's multiplied by 1 take x. So what I'm actually going to do now is just make it 1 take x on the numerator of that fraction. Okay. Now I'm subtracting 2 root x times negative 1. So that's actually going to make this a plus for starters. And it's going to make it plus 2 root x. Now, you'll notice on this numerator as a whole, so I'm talking about, just to make it really clear, I'm talking about this numerator here. To add these together now, I need them to be on the same denominator. So if I want 2 root x to be on root x, I multiply it by root x on root x. So I'm going to have 2 root x times by root x on root x. Okay. So technically, I'm just multiplying it by 1. I'm not changing its value, but I'm getting it on that same denominator so I can work with it. And on the bottom line, I'm not going to expand it out. I'm just going to leave it as 1 take x squared. So scrolling down, now I end up with root x on the denominator up here times 1 take x squared. Okay, it's not times, sorry, all on 1 take x squared. And at the top here, I've now got 1 take x. And then 2 times root x actually just gives me 2x. So that's going to be plus 2x. All right, so it's looking a bit better. Now, just remember, in this kind of scenario, I can actually just bring this denominator down, so the two denominators merge. The way to think about this is if you've got A on B on C, that's A on B times 1 on C, which gives you A on BC. Okay, so this is, and on the top line, 1 take x plus 2x essentially simplifies to x plus 1 over root x 1 take x all squared. So we go, all right, when is this function equal to 0 and when is this function undefined? So really importantly, a quotient function like this will equal to 0. So when does dy dx equal to 0? Well, it's going to equal to 0 when the numerator equals to 0. Okay, so that's going to be when x equals to -1. So that's the only way this function can be 0, is when that numerator is 0. When is it undefined? Well, it's undefined when the opposite, well, not the opposite thing, but yeah, kind of the opposite thing, when the denominator equals to 0. So that denominator is going to equal to 0. Well, if we use our null factor law, remember the null factor law says if I've got two numbers and they're multiplied by each other and they equal to 0, then either A0 or B0, okay, or both, of course. So undefined, so it's undefined when root x times 1 take x squared equals 0. Now, that's going to be when either root x equals to 0, so therefore, or 1 take x squared equals to 0. So therefore 1 take x would equal to 0, which means x equals to 1. Or over here, this is only true if x equals to 0. Okay, so we've got now two values where it would be undefined. Really importantly though, the other thing that can't happen is I can't do the square root of a negative. So I can't do the square root of -1, for example. So x also has to be positive. Okay, so essentially it's undefined. I'd have to make a statement like this. So dy dx is undefined when x is less than or equal to 0 or x equals to 1. Okay, so I hope this has made sense. Once again, if not, let me know and I'll add some clarity or answer the questions you may have.